right, so now what we're going to do is we're going to look at the sine of two different angles. And again, remember, these are angles that are going to intersect the unit circle at a point that we're familiar with. Because, if you think about each of these angles, these original angles, pi over 3 is the same thing as 60 degrees, which is from our special right triangle. Pi over 6 is 30 degrees, which is from our special right triangle. And pi over 4, which is 45 degrees, is same as our special right triangle. So again, if you remember, we created the special right triangles to find the points on the unit circle. And that's basically the idea I'm going to use. I will kind of create this and go through the points, but if you need to kind of reference that, make sure you have the unit circle in front of you so you can kind of like follow along. So again, if I want to evaluate for the sine of pi over 3, I basically just need to know like where is the point on the unit circle where the angle pi over 3 would intersect. So I'm just going to do a quick little unit circle, not the whole unit circle, but just for what I need. Okay, so I know pi over 3 is roughly like 60 degrees, right? So that's like right there, and that is that angle. I'll actually zoom in here. So there's angle pi over 3, and based on the unit circle of what we created, I know that this coordinate point is going to be 1/2, comma, square root of 3 over 2. All right. Now, so if I want to evaluate the sine, remember we talked about the sine of any point that's on the unit circle, right? The radius is 1. We know it's just going to be the y coordinate. So the sine of pi over 3 is just going to be square root of 3 over 2. As easy done, right? Now let's go and take a look at the sine of 4 pi over 3, because that's a different angle, right? It's still in thirds. So if we kind of go around the circle here, if we go from here to here, we know that's pi, right? Otherwise known as 3 pi over 3. And therefore, to get to 4 pi over 3, I just need to go an extra third. So I'm going to go from here to here. I'll just put an arrow there too as well. So the angle 4 pi over 3 is down here. And what you can see is my graph is not, or my circle is not the best, but you can see that this is a direct reflection, right? It's basically a reflection about the origin. So the x and the y are both being reflected. So what that means, if you remember when we looked at like symmetry about the origin for odd functions, both my x and my y are now going to be negated. And we'll look at this another way as well. So now, obviously, since I'm in the third quadrant, x has to be negative. And since I'm in the third quadrant, my y has to be negative. Okay, so now if I want to look at the sine of this, I'm looking at the y coordinate again, which is going to be negative square root of 3 over 2. So this would be a negative square root of 3 over 2. But there's something else I want to talk about, because obviously if you know this point in the first quadrant, and then you could also recognize that this is just a reflection down. But there's another thing we can look at here. And the other thing we can understand here is the reference angle. The reference angle of our first quadrant point is exactly the same as our angle, right? Because it's in the first quadrant, which is pi over 3. Well, if I was just to graph this like 4 pi over 3, I would recognize that again, I went to 3 pi over 3, then I went to 4 pi over 3. So the measurement, the measure from my terminal side to my x-axis for this angle is again the same reference angle. So it's again pi over 3. And what I want you to understand is when you have two angles, or just an angle that has the reference angle, like whatever that reference angle is, you can obviously see that's going to be the same value as what it is as in the first quadrant. Like for instance, so here's this angle 4 pi over 3, has a reference angle of pi over 3. Notice it's the exact same value of the reference angle, right? Because the reference angle is of that angle in the first quadrant. These are exactly the same. So if I know the reference angle here, I know that the value is going to be square root of 3 over 2. The only thing now I need to do is apply the sine based on the quadrant that the angle lies in. And you can see here the angle lies in the third quadrant, so therefore the y coordinate must be negative. Now let's go and take a look at another example here with, let's do green here. Let's look at 5 pi over 6. So I'll kind of use, let's do it again. Let's just do a different triangle. I think I have room. So let's do 5 pi over 6. Okay, so in this one, we have pi over 6, which again is the same thing as 30 degrees. So that's going to be a smaller angle right there. Pi over 6. Okay, based on our unit circle that we have, we know that this quadrant point is 1/2, comma, oops, sorry about that, square root of 3 over 2, comma 1/2. So this is going to be square root of 3 over 2, comma 1/2. Okay, so in this case, you can see that the cosine is square root of 3 over 2. All right. Now, if I'm going to graph 5 pi over 6, again, we got one thing we want to do is like recognize this. Well, yes, we can graph this. We know that halfway around a circle is pi, otherwise known as 6 pi over 6. So if I'm pi over 6 short, right, I'm at 5 pi over 6, then I know that I'm just going to be pi over 6. And again, what we can do is we can look at this as a reflection and know that since it's the same coordinate point just being reflected over. But we can also, rather than just looking at this as far as the angle, as far as being 5 pi over 6, we can understand this by using the reference angle. Because we know the reference angle here is, again, pi over 6, right? The distance from the terminal side to the x-axis is pi over 6. The distance from the terminal side to the x-axis is pi over 6. Since these have the same reference angle, their values are the same. So the value of pi over 6 is square root of 3 over 2. Since this angle, 5 pi over 6, is in the second quadrant, I know that it's just going to be negative square root of 3 over 2. And if you want to use your understanding of reflections, you know that when you reflect this about the y-axis, the x-coordinate would be negative. So that's why we get negative square root of 3 over 2, comma, 1/2. So it's just a couple different ways to look at this. I just like to, obviously as you're getting used to this, you can work on the practicing of the graphing. But, my point is to be able to do this efficiently is to look at the angles. And there's really two things you need to want to start looking to ask yourself, like what is the reference angle and what quadrant does the angle lie in? Because if you know the quadrant and the angle, if you know the reference angle and the quadrant the angle lies in, you can evaluate any trigonometric function as long as you know the first quadrant. All right, so let's do this last one here for tangent of theta, or tangent of pi over 4. So pi over 4 is, again, the same thing as 45 degrees. Horrible circle, but that's okay. We're just going to keep it. So that's pi over 4. Okay, and you can see that that quadrant, or that point, is square root of 2 over 2, comma, square root of 2 over 2. All right. Now, again, let's just graph negative pi over 4. Well, that's going to be the same angle, but now just in the negative direction, right? So that's negative pi over 4. And again, if I just go with my reasoning, I know that the reference angle is the same. The distance from the x-coordinate to the terminal side is the same for both of these angles. So remember, the tangent is the y-coordinate over the x-coordinate. Since these are exactly the same, we know we're going to equal 1. So if I did tangent of pi over 4, obviously that's equal to 1. Now, I noticed, though, even though this is going to be the same value, I noticed that tangent of negative pi over 4 is in the fourth quadrant. Therefore, tangent is going to be negative because tangent is negative in the fourth quadrant. And the reason being is because we have a y-coordinate is negative. And let's write the point, and you could see that. So it would be square root of 2 over 2. Comma, negative square root of 2 over 2. So when you put a negative square root of 2 over 2 over a positive square root of 2 over 2, you'd obviously get a negative 1. But again, it's just kind of looking at these reference angles and understanding and remembering, which quadrants or which functions are going to be negative for each value. So that's kind of really the power of the reference angle. It can help you out, help you evaluate the trigonometric functions a lot quicker rather than always having to, graph it and then try to think about where is this point on the unit circle. If you know this first quadrant in the unit circle, then all you got to do is find the reference angle in the quadrant and you can kind of refer back to it. So now let's go and look into some different angles which we call coterminal.